Hello my dear students, good morning to all of you and welcome to e-learning classes of Untitled English Academy. I am Mr. Injamul present here to take your maths class and I will be continuing my class for the students of class 12. So, in my class I am going to discuss a new chapter and today's discussion will be going on the chapter binary operation. Okay. So first you have to know what is binary operation. So before going to my main discussion, you have to know about the operations. Okay, I hope all of you know that in mathematics there are four fundamental operations. Those four fundamental operations are: one is addition, subtraction, multiplication and division. These four operations are called fundamental operation in mathematics. So now question arises, in mathematics there are only four operations? No. Actually, except these four fundamental operations, actually these four are fundamental. Okay, except these four operations, there are so many operations and we can generate or we can make more operations by combining these four. By combination of these four. Okay, I am giving you an example. Suppose I am generating an operation star. I am introducing you with an operation star, and star is defined by, suppose, a star b equals to a plus b minus ab. Okay, if I ask you about what is 7 plus 2, easily you can say that 7 plus 2 is 9. Why? Already you have introduced with the operations plus. Okay, but you don't have any idea about the operation star. But right now I have given how to solve or how to compute the value of a star b. That means easily we can compute 7 star 2. What is the 7 star 2 value of? So a is 7 plus 2 minus 7 into 2. So this 7 plus 2, 9 minus 14 equals to minus 5. Okay. Hope you get an idea of new operation star, which is defined into this way, and 7 star 2 equals to 0. Now clearly, since you have already introduced with this operation, so easily you can find out what is the value of 2 star 3. Okay, and 2 star 3 will be 2 plus 3 minus 2 into 3. So this is nothing but 5 minus 6 equals to minus 1. Hope you get the idea. Okay, and this is the operation. See, we have made this operation by the combination of three basic fundamental operations, and the four fundamental basic operations are these four: plus, minus, multiplication and division, and I have used here addition, subtraction and dot is there, so another one is multiplication. So by use of plus, minus and multiplication, we have made this new operation. Okay, so in this way you can make many operations. Okay, but these four are fundamental. Is it clear to you? So I am making one more operation, a star b, a compose b, sorry. I am going to introduce you with the operation compose. And a compose b, suppose I am giving you the definition of compose in this way, that a square plus b by a plus b, in this way, or whatever, a minus b, write it, it will be better, a minus b. Okay, so I have introduced you the new operation compose into this form. Okay, so if I am asked you to compute the value of 5 compose 7, then easily you can find out it. So 5 compose 7 equals to what? 5 square. Here A means 5 and B means 7, so 5 square plus 7 by 5 minus 7 equals to 25 plus 7 by minus 2 equals to 30. Equals to 32 by minus 2 equals to minus 16. Hope you get the idea. And this is the new operation which I have introduced to you, and this is the combination of addition, subtraction. A square is there, A square means A into A, so this is the concept of multiplication, and by is there, so this is the division. So this is the combination of 4 fundamental operations. Is it clear? So except 4 fundamental operations, you can make more operation. Hope you get this idea. Okay. Now our chapter name is binary operation. Okay. So now question arises that when does an operation is said to be binary? So I am telling you that such an operation, not only about plus, minus, multiplication, and division, not only about this all type of operation, this operation is said to be binary. Binary operation, first of all, it is an operation, and if that operation satisfying a condition, a small condition is there, then that operation we can say this is binary operation. So now we have to know about the condition. Okay, let's go. Binary operation always will learn on a set, and the set should be non-empty. Okay, actually on the set empty, most of the properties are vacuous to, that's why our interested and our focus will be on non-empty set. Okay, so non-empty set means what? A collection of some numbers or whatever thing, well defined collection, and there will be at least one element. That is called non-empty set. Non-empty means it can't be empty, at least one element will be present there. Okay, so suppose I am considering a non-empty set A. Suppose this is the set A. This is the set A, non-empty, and some elements are there. Clear? Now we will learn the binary operation on the set A. Okay. Suppose I am considering an operation star. This is an operation. Up to now, this is an operation. Okay. Now we will check that this operation is binary or not. So how to check that this operation is binary or not? The checking procedure is, first see this part, after that I will give the definition. Then it will be better to you, and you will be better understand the definition of binary operation. Okay. So this operation star is said to be binary operation on this non-empty set A if, suppose there are so many elements, and if you consider any 2 elements from this set, any 2 arbitrarily, you can choose any 2 elements from this set. Suppose I have chosen here the element A, arbitrary element, and another element B, and you can choose any 2 elements from this set A, and if we operate this operation star among these 2 elements, then it will become A star B, and A star B will itself a number. Whatever number you will get, this resulting number or resulting element, if also the member of the set A, then we can say that star is an binary operation on the set A. Is it clear to you? If you choose arbitrarily any 2 elements from the set A, after operating the operation A star B, the resulting should be the element of A. If the resulting is an element also in A, if the resulting is also an element of A, then we can say that star is a binary operation on the set A. Is it clear to you? So now write the definition. Definition will be like this: binary operation. Let, first consider a non-empty set. Let A not equals to 5, a non-empty set. No need to write, be a set. Okay. An operation, I have declared here only operation. Okay, an operation star is said to be binary operation. If for A comma B belongs to A, I have arbitrarily chosen here, A comma B belongs to A star B has unique value. Unique is very important, unique value in set A. Okay, actually A star B will be unique. So this is the definition. Okay, we can give the definition of binary operation into this way. This is the graphical representation of the definition. It should be unique. Okay, it is very important, unique. And this is the actual definition, that A be a non-empty set. An operation star is said to be binary operation if for A B belongs to A. That means we can arbitrarily choose the element A B. A star B has unique value in the set A. That means A star B has to be a unique value, as well as A star B must be belongs to the set A. Okay, in A means belongs to the set A. Hope you understand this thing. A star B belongs to the set A. Clear? So this is the definition of binary operation. So hope you get the idea that when does an operation is said to be binary. Okay, I have given here the definition of binary operation independent of the concept of mapping. We can give the definition of this binary operation in terms of mapping also. Okay, I will discuss this part in terms of mapping later. Actually, in terms of mapping, your realization will not come properly. That's why I have given into this form. Let's go to some example, and I am considering some example of binary operation. That means you have to check whether the operations are binary or not. Okay. Suppose we consider the set natural number. Hope you know about natural number. Natural number means 1, 2, 3, 4, 5, 6, all these things. Now check whether set n, on the set n, that means set of all natural number, check whether the following operations are binary or not. The first operation is plus, minus, multiplication and division. These are well known operations. That's why we no need to define it, how to define this. But the fifth one is star and defined by A star B equals to A plus B minus AB. So you have to check one by one. First see the first one, A plus B. Is it binary? So how to check that this operation is binary or not? This operation is said to be binary on the set natural number. Okay, That means if you choose any two number arbitrarily from this natural number, suppose I have considered here A, one number, and another number B, and after adding, plus is there, so after adding the resulting will be also a natural number or not. Just you have to check this part. And as we know the property of natural number, that sum of two natural number always a natural number. Okay. So no need to check it in particular. You can check that 2 is a natural number, 3 is a natural number. Then 2 plus 3 itself obviously a natural number. Okay, this is a particular example. So as we know that sum of two natural number always a natural number, so we conclude that plus is a binary operation on the set natural number. Okay, so first one is binary. Done. Next, subtraction, second one. Second one is negative. Are you sure that negative will be the minus will be binary operation on the set natural number? We can't get a decision. Okay, let's check. Suppose we have considered a number 5 and another number 2 from these two natural number. Then 5 minus 2 equals to 3. Very good, it is a natural number. After operation we get a natural number. But if someone choose 2 at first, after that 5, then 2 minus 5 equals to minus 3, and it is not a natural number. So we can say that the negative is not a binary operation. This is not a binary operation on the set natural number. Next, third one, multiplication. Obviously product of two natural number always itself a natural number. You can choose any two natural number, then after multiplication the resulting number must be a natural. So multiplication also be a binary operation. Now what about division? Are you sure that if you consider any two natural number and after divide these two natural number you will get a natural number? Are you sure? No. How? Just see an example. Suppose I have considered here 2 and 12. 12 and 2. These two are natural number. Then if we divide 12 divided by 2, then 12 divided by 2 equals to 6, itself a natural number. But what about suppose you choose 6 and 5? These two are natural number, but 6 divided by 5 means 6 by 5, which is not a natural number. Okay, so this is not true. From the definition, according to the definition, what? You can choose any pair. For any pair, after the operation, the resulting number should be in that set. So it is my wish that I have chosen here 6 and 5, and 6 and 5 if we divide, then the resulting is not a natural number. So this result is, for fourth number is, it is not a binary operation. Okay, now check the fifth one. Okay, fifth one is exceptional. Okay, for fifth one, it is very difficult to say like plus, minus, multiplication and division. Okay, actually this is also not a binary operation. I can evaluate the definition. How? Suppose so many examples are there. If we take 7 and 2, okay, belongs to natural number, then 7 star 2 equals to what? According to the definition, it will be 7 plus 2 minus 7 into 2. Okay, so 7 plus 2 means 9 minus 7 into 2 means 14 equals to minus 5. It is not a natural number. It is not a natural number, so it can't be a binary operation. Hope you get the idea. Next, M is a set of 2 cross 2 matrices. A, B, C, D, where the entries will come from integer. Okay, now check whether matrix multiplication is a binary operation. To solve this problem, this is very easy. Actually, it will be a binary operation, matrix multiplication. Why? If we consider any two matrices of 2 cross 2, suppose arbitrarily I am A1, B1, C1, D1. Suppose this is one matrix and another matrix A2, B2, C2, D2. These two matrices from the set M. Now multiply these two matrices. If you multiply these two matrices, then we will get A1, B1, C1, D1 dot A2, B2, C2, D2 equals to, if you multiply, then it will come A1, A2 plus B1, C2, A1, B2 B1, D2, C1, A2 plus D1, C2 and C1, B2 plus D1, D2. Now we have to check, this is the multiplication of two matrices and this is the resulting matrix. Now we have to check that this belongs to the set M or not. When does a matrix exist in the set M? If all the entries are integer. See here, A1, B1, A2, B2, C2, all these things are integers. So this part is an integer, this is also integer, this is also integer, or this is also integer. Why? Since we know that sum of two integers, product of two integers are always sum, subtract and product of two integers are always integers. So all the entries are integers, so we can say this belongs to the M. So in general we can say that the matrix multiplication is a binary operation. Understood? Next, some properties. Next we have to know about some properties. Okay. First property which I am going to discuss, associative property. Associative property. Actually, this is very well-known property. Why? You have learned about associative property in lower class. I am discussing here about previous concept. You know the associative property for addition. Associative property for addition was previous knowledge. This is previous concept. Okay. Associative property was A plus B plus C. This can be written as A plus B. We can add the first two and after that the third one. So this was the associative property. This was the associative property for addition. Okay. So now I have introduced you with the binary operation. So we have to learn this property for binary operation. So to learn for binary operation, we have to consider a binary operation. So let star be a binary operation on A. A means that set. Okay. Then associative property is A star B star C equals to A star B star C. That's just in the place of plus we have written here star. Okay, if an operation satisfies this property, then we can say that this operation satisfies the associative law or associative property. Clear? My next property is commutative property. Okay, what was the commutative property? According to our previous knowledge, for addition, commutative property was A plus B equals to B plus A. That means if you add A plus B and B plus A, then you will get the same result. Okay, this was the distributive property for addition, and there is no distributive property for subtraction. Why? If you consider 2 and 3, then 2 minus 3 and 3 minus 2, these two will not give us the same result. 2 minus 3 means minus 1, 3 minus 2 means 1. This is minus 1, this is 1. That's why there was no commutative property. That means commutative property is not true for subtraction. But in in binary operation, an operation is said to be commutative. An operation is said to be commutative if A star B equals to B star A. So I am writing here, this is associative property. Second, A star is commutative. If A star B equals to B star A for all A comma B belongs to the set. This is the symbol of for all. Understood? So this is the commutative property. Okay. Next property is distributive property. So what is distributive property? In your previous concept, distributive property was, suppose A dot B plus C. This can be written as AB plus AC. This was your previous concept. This is known as distributive property. So look properly, then you can observe that in the case of distributive property, we need two operations. See here, one multiplication is there, another plus is there. Okay, so we need two operations. So if we discuss this distributive property in case of binary operation, then we have to consider two binary operations. So I am considering here, let star, this is one binary operation, and compose are two binary operations, on A. Then A star B compose C equals to, just we have to distribute. So first one will be A star B, like the same way, A star B compose A star C. This is one, and another one will be A compose B star C equals to A compose B star A compose C. So this is the first distributive property and this is the second distributive property, and these two togetherly called a distributive property in binary operation. Okay, hope you get the idea. So up to this you got the idea about binary operation. That means when does an operation is called binary. After that, some properties of binary operation. Okay, next you have to know about identity element of a set. Okay, under a binary operation. So first I have to discuss the definition. Let's go. In a set A under binary operation. Okay, I am not writing. Okay, identity element in a set. I am discussing in graph. Suppose this is a set A, capital A. Okay, and there is a binary operation star. This is binary operation. Keep in your mind. Note it. This is binary. Okay. And there are so many elements, so you have to identify the identity element. So first you have to know the characteristic of identity element. There are so many elements. An element I named as E. An element E in the set A, this set is said to be the identity element if this element has the capability to give back every element. That means suppose there are any other so many elements, and if we apply this operation star, suppose I am considering any one element A, then A star E ultimately will be A. Okay, and this thing will be happen for any other element of this set A. That means suppose in a room we are 5 persons. Okay, then I have to be declared as identity element if with any other students or any other persons, if he operate with me, then I will give back himself only. Understood? Then I have to be declared as identity element. The characteristic of identity element is this. So write the definition. Let star be a binary operation then if there exists an element, this is the symbol of there exists an element E belongs to A such that, now write the characteristic, A star E equals to E star A. That means you can do first A after E and E after then A. It will give back A, and this will be happening for all A belongs to the set. Okay, so this is the definition, that let star be a binary operation. Then if there exists an element, if you get the existence of such element, then you can say identity element exists. Otherwise identity element does not exist. Is it clear? So this is the definition. Clear? Now I am considering some examples. Suppose number, if we consider the natural number, set of all natural, then clearly dot, that is multiplication, is an multiplication is a binary operation. Okay, now we have to find out the identity element. Clearly 1 is the identity element. See, 1 belongs to N, and the characteristic of 1 is if you multiply any natural number with 1, then you will get back the element 1. That means this is in the place of Mr. it is multiplication. Then you will get back A, and it will be happened for every A belongs to N. So 1 is the natural identity element under this operation. Is it clear? Next, one more example. On the set Z, clearly plus is a binary operation. Plus is a binary operation. On the set Z, plus is a binary operation. Suppose we are going to find out the identity element, whether identity element exists or not. So here you have to find out that element whose characteristic will be, if we add any number of the set Z with that number, then you will get back. So here identity element will be 0. Identity element is 0. Why? If you consider any integer a, then a plus 0 and 0 plus a, whatever, you will get back a again. And it will be happen for any a belongs to Z. So we can say that 0 have the characteristic like, 0 has the characteristic like identity element. So on the set Z, under the binary operation addition, 0 is the identity element. Identity element will be unique in a set. Understood? So this is the concept of identity element. Clear? So today's class is up to this. I will discuss the next part in my next class. So till then, take care and goodbye.